My name is Linda McFerrin. I'm from the biology department, and my partner Jake Casari is not here today. But we did a project about scientific terminology in our classes, and does excessive scientific terminology interfere, impede students' ability to learn how to design experiments? And there's some research to show that, and a lot of jargon tends to prevent students from learning concepts and from learning the big picture. And so we have struggled in our PACE ecology class to teach students how to design experiments. They struggle. This is a particular group of students that have, that start out with not such good research skills and a pretty big fear of science and biology. So it's kind of a tough crowd. But for this group, we are looking to see if cutting out some of that terminology helps them learn how to design experiments better. And I don't do this with my biology majors class because they do need to know the terms. And the terms in terms of designing an experiment would be things like control group and a treatment group, what are standardized variables that you keep the same in both groups, how many samples you take, are you randomizing the samples. These are terms that we do need if you're a biology major, but the biology non-majors don't need it. But Jay and I do feel that it is really useful to know how to design an experiment, so you can get, because this is information that you get in the newspapers, experiments show that you should be drinking more red wine. Well, should you? Is it a good experiment? You should have some ability to assess information so they can make decisions about stuff. So anyway, what we did was we asked students to design an experiment. I'll show the question. We did a pre-assessment at the very beginning of the semester before we even talked about experiments, a post-assessment after I spent a lot of time teaching them about scientific terminology, control group, treatment group, standardized variables. And then a week and a half later, we did another assessment at some point after the first post-assessment, we said, okay, we're not going to use any of the terminology again. We just want you to make sure you have a well-designed experiment. And we told them the elements of that would be lots of samples, repetition, keeping your groups really similar so that the manipulated variable is only different. So we used plain language and said you don't need terminology anymore, but you need a good experiment that will convince people when you're done. And so the second assessment was a week and a half after we spent some time practicing without terminology. So Jay and I wrote a rubric to assess their experiments, which I'll show you. We had 34 students that we assessed and analyzed. Being biologists, we analyzed the data with a t-test. So here's the question. And again, in this question, you can see our attempts to remove the jargon already. This is something that I do in my biology classes. There's so much terminology that it's very preventative, in fact. And then what happens with retention is the jargon is always the first to go. So I want them to remember concepts and ideas anyway. So here's my jargonless statement. There are a bunch of lakes. About half the lakes are near a large farm and others are not. Some people have suggested that there might be less fish in lakes near the large farm. How would you go about figuring out if this is true? Very jargon-free. So they have to answer A, B, and C. What's the hypothesis? Now it's interesting, I realize hypothesis, I could have taken that out as well. How would you test this hypothesis? And the third part is really important because sometimes they don't think about all the elements they might need to be convincing unless you ask them this part, which is, will the test provide convincing evidence why or why not? And sometimes in that third part, they add parts that show they really do know how to design a good experiment, so we added that in as what they needed to answer. So I will say that on the fourth time that I asked them to answer this question, the PACE students were like, again? Oh, didn't we already do this? Anyway, it was a struggle. I had to, at some point, just give them points for doing it. So here's the rubric that we wrote, and it's it's a scale from 0, 1, 2, and 3, and I'll read it because it's really tiny type. 0 points would be stuff that's off track, emerging, accomplishing, and mastering. So A, there are 3 points, up to 3 points for defining your hypothesis. So if you say, and a lot of students actually wrote stuff like, there's a lot of pollution that's killing off the fish. Well, that's not really a hypothesis. And then we go all the way here, the hypothesis should say, lakes near the farm that are otherwise similar to lakes far from the farm will have less fish. Or I essentially as long as they are asking or making a prediction about more fish in the farms that are farther away. B and C, so B is the experiment test, and C is so B is whether your experiment is testing the question, and are there details so that somebody would know how to do your experiment. And the C is a separate grade, it gets a separate grade, which is the experiment details of, do you have enough samples, did you randomize, do you have standardized variables so that you're thinking about, making sure you're sampling on the same day. And so there are very specific things that are required for the different scores. So for off-track, explanations that lack sufficient detail, explanations that mention none of the concepts about replication, randomization, standardized variables. And then you move to explanations that have sufficient detail, explanations that mention one of those three concepts, explanations that mention two, and explanations that mention all three. So if they mention all three, lots of samples, randomize your samples, standardized variables, you got a score of 3. So I scored all of their experiments, and they did a lot of them, so I scored a lot of the experiments. And something that would be helpful, I'm sure, would be to make sure that that scoring process is consistent and internally valid, but I didn't have time to do that. And here's the results. So this is rubric scores for the experiment question with and without scientific terminology. So this is the score. Essentially, the total score they could have gotten was 9, because they would get 3 for each of the 3 sections. And before class, basically before we did anything with experiments, the score on average was about 3.6. After the first post assessment was after we talked a lot about scientific jargon, and their score was 5.2, 5.3, and the post number 2 was after we told them, okay, no, you don't need the scientific jargon, let's just get a really good experiment. And that mean was, I think it was 5.7. And so, unfortunately, the post with terminology and without terminology didn't really show to be statistically different. It's a little higher without the terminology, but I will admit that this post-assessment came after they'd had additional practice, so it's a little hard to compare. On a positive note, the post-assessments were statistically higher than the pre-assessments, which means that they did learn how to design scientific experiments. So I guess I just said that. No statistical difference with the terminology and without, but like I said, they did learn something, which was different than my last FIG, where it actually showed that they actually had no improvement at the end of the semester. So Jay and I feel good about ourselves. We're actually teaching them some stuff this time. So some limitations, there's only 34 students, and I had intended to do this in 3 of my classes, but I only ended up doing it in 1 class. Another limitation is this ecology class most of the students have Saturday instruction, but a handful do not, and I didn't separate out the data, the students, because I didn't have enough time to do that. And also it includes PACE students and non-PACE students, so it's a pretty big mix of students. If I had to do it again, I would definitely separate out those 2 populations. And as I said, there are certainly, as an experiment, there are lots of uncontrolled variables. The timing of when they had to answer this question, I always tried to make it at the beginning of class, so they were fresh and not tired, because class is at 7 p.m. But you never know in terms of whether it's come after an exam, or one of the assessments came the week before an exam, and there's all sorts of stress for the students. I did actually analyze a separate set of data that was data from an exam, although that's also like a different context for answering the question. But that data didn't show any differences in the other data I collected. Future inquiry, well, I still think this terminology issue is an issue. I do think that the excessive jargon will impede their understanding of the big picture in some ways. And so I really am curious about doing more with the data set I have, and then repeating the data in other classes. And it might be nice to randomize when they get the terminology. So maybe test students and not give them terminology in the first half of the semester and give an assessment, and then do it where, okay, now we're going to put some terms to what we've been learning and see if there's differences depending on which one goes first. What's on the side? Something else I was going to say about that. It is possible that, and this is something that I have thought of too, is that the terminology might actually give them a framework for putting the pieces that they actually really need. And so I can see how it may not actually be significant no matter how many times I test it. And so I really don't know, which way to think about that. Another thing that I have thought of, it's funny because as a biologist or scientist, I don't think of taking qualitative data, that's not one of my first thoughts, but surveying the students about what they think is hard about learning experimental design would be, I think, another step. And then I still omit terminology, even for my biology majors class, in favor of the big picture and concepts. So I still continue to do that. Questions? Yes?
Have you considered, since you have more than one section, having one section with the terminology and one without? And did you decide not to do that?
I have different classes, so human biology, ecology, so it's not exactly.
You don't have more than one section of the same
No,
class.
and I have a human biology at Holy Names, but wow, those students are really different.
Yeah.
So I don't have, something where I can do half and half, because that would be nice.
Yeah.
If is one of the questions you have that if they hear the terminology, that even if you use it and language that defines the terminology, so both kinds of language, is it just that the terminology gets in the way because it's too many different concepts at once? Or?
Something that students have said is when they hear that term treatment group, it makes them think that you're like a doctor treating an illness, and like they just kind of go in a different place mentally, and they tell me that the treatment idea is just, I don't get how that's a treatment, when you talk about, a fish with, the larger ponds and the smaller ponds.
Well, because we do teach, and we're in PACE too, that we have this discussion that it's fascinating to me. If you use the term thesis, I don't know if you guys run into this. Thesis. It's like or theme. A theme is another example. If you use the term theme, I cannot get my students to feel comfortable with it. There's certain terms that if you use the word message, they get it better.
Well, it's a little bit like hypothesis. If you say, well, it's just an educated guess, anybody can make an educated guess. Like when I first start talking about experiments, they look at me like, well, we can't do experiments. And I say, well, anyone can make an educated guess about what you think is happening here in this situation. And so I do that a lot when I'm teaching anyway.
Yeah. Because I think a number of students, that they're afraid to put the word on, to take it on as if that they're faking it if they use it even.
I think that's true too. Yeah.
I have a suggestion for a qualitative study. You could perhaps just have them write difficulty papers or reflection papers, just no more than a page, and no concerns for grammar or spelling in this context. Just get your feelings out there, talk about it, and if you're not comfortable talking in person, write a paper about it.
Yeah, I agree. I think that actually would be helpful. I tend not to think like of getting that kind of data, but yes. David.
I was wondering if you found out that anyone else has done research on this topic and what they had to say.
I finished my last class yesterday, so the answer to that is no, but I'm sure there is. I'm sure that
Maybe not.
I don't know about studies like this, though, actually looking at, I think I have a feeling there's some research, but that's a good question. I should do that before my final reports.
You could also do a Kung Fu terminology game. Use the math, use the words.
And fear isn't the only issue. It isn't necessarily all about fear for everyone, at least in terms of grammatical terminology. Some of it has to do with we remember terms that we have used for. And when we use them repeatedly, we remember those terms. So that's why I think that's part of the reason so much research has shown for native speakers that when they learn grammatical terms, even if teachers spend a lot of time teaching it and students remember it, a semester later, a year later, they've forgotten it all. Because they're not going to go through every sentence thinking, this is a subject, this is a verb, this is
Yeah.
direct, they're just not going to.
And if we English teachers, it's useful for us and we're interested in it, so we have all,
Right.
yeah.
And ESL students or English speakers who learn a different language need that terminology
And then there's
to
a big
study the
question.
language.
But how do we?
Grammar is beautiful, I love grammar.
Right.
See,
You
you're
get
not-
one
you're
rule
not-
and you can just, the
I
whole
do
world is
too,
opening.
I do too, but for many students who maybe don't have that same love for one reason or
Yeah,
another.
but I mean,
It's not
No, but I mean, we
useful.
can't, yeah.
They're not applying it on a regular
The problem
basis.
is,
They're
how
not
do we
gonna.
talk about it? That's the big question. How do we talk about it if we don't have a word for
But
it?
I do think, though, that looking at how terminology gets in the way, one of the things we might want to look at is why it gets in the way.
Yeah.
I mean,
Yeah. I
it
think
might
so.
be fear.
it's a
I think
great
for
idea.
some students, there is this
Intimidation.
issue of feeling like a phony,
Yeah.
using
Yeah.
certain terms.
Mhm.
And then when they do
Intimidated
learn to use
by-
the terms, they're more in an
Part of the
academic
club,
way of
yeah.
thinking, they're part of the club, there are all those issues. But there's also the issue of how much is it actually being used?
It's just context free, so it doesn't stick.
Right. It doesn't stick if you
Yeah.
don't use it.
But I think too that the terms and
Yeah.
the words themselves are also, they have another idea of what that might mean, or they have misinformation about what they mean.
Right.
Might mean, the word adaptation in an evolutionary sense is really difficult when people think that you adapt to the weather by putting a coat on, So, and they have this idea already, so that's also hurting their learning.
Yeah, because there's one word can mean different things.
Yeah.
So
And they
it's-
already have
the
what they think it
associations
means.
with
Yeah.
certain kinds of words.
Yeah, exactly.
Jenny, what was it you